Hello everyone. I was too lazy to change my setup back, so I'm still streaming on the left side of my desk. Oh well. Alright. Um, I hope no one has been following along too closely what I've been doing with modifier keys in my code lately, because I was just debugging something. That is the diff for the fix that I made. And a week or two ago, I did the exact opposite. Removed this, added this. Added this, removed this. And now I'm reverting that. So yeah, hoping nobody's been paying too close attention. Otherwise, you will realize the mistake that I've made that I've just explained to everybody. Anyway, just gonna finish this real quick. And push it. And okay. Now, good news, the reason I found out there was a bug with modifier keys is I was able to run my text editor wearing a terminal mask on the operating system directly. So I haven't really prepared my build system to do this part that I'm doing right now manually, but yeah, we're good. We should be good. So hello, Blurry Square, Waddle Fox, and Dulce, and Stream Elements Bot, who only works on Sundays, by the way. I pay you for 7 days, you work 1 day a week. Insane. Alright, it runs in here now. Although, I do realize the size of it is weird. And also, zooming is not exactly a finished feature, so it works like this. But, there we go. Beautiful. Absolutely beautiful. Actually, like, the system can zoom. Oh, that's a new one. Okay. It can zoom. It's a feature that I added once in like 5 minutes to think, can it do that? Would it be difficult to add something like that? And the answer was no. And then I kept the code there, but I just kept it commented out, and I decided to add it back in. So it's not a super polished feature, which is why it did all that. But most importantly, to scroll, you use the scroll wheel, which doesn't check if you're inside of a program or not. Which means you could be trying to scroll inside of here and you end up scrolling the system. So maybe I want to disable that. Probably want to disable that. If I remember how to do it. Here. Oh, there's a setting for it. Okay. Well, I'm just going to disable it in my settings then. Use... where is it? It's called Use Desktop Zoom, which I do not have enabled. Is it on by default? Oh yeah, it's on by oh no, that's not supposed to happen. Yeah, okay. So that should fix it. Why was I in debugger mode? I don't use debuggers. They disappoint me. Okay, I can't zoom anymore, that's good. Hello, Andreu. Welcome. Alright. Alright. We didn't come here to zoom. We didn't come here to, what was the other thing I was doing? Work on modifier keys. Although, actually, we did do that. I do want to talk about that in a minute. But we're here to do scripting. And officially, hold on, this part I actually do want to do inside the operating system. Officially, I can run my terminal that is definitely not a text editor wearing a terminal costume. And it should be able to please work. I haven't actually tried this in the system. Run Lisp. It can run Lisp. Okay, that's beautiful. That's beautiful. It works. It runs Lisp. There's still a little bit of polishing to be done to that. For example, the output is a linked list, because Lisp, the list processing programming language, uses linked lists for everything. So the output is technically represented as a linked list, and my printer doesn't care much for, you know, pretty formatting or anything like that. So when I did add 1, 2, it printed the result 3 and then nothing after that. So it's a null terminated linked list. Kind of. No, wait, it is literally a null terminated linked list. It's kind of disturbing to think of, but it is that. All right. Oh, the only reason that's disturbing to think of is because of C null terminated strings. They're traumatizing. Aren't all linked lists technically null terminated? Yeah, they all are. Never mind. That was not a deep observation. All right, so yeah, the scripting language that I'm going for my terminal, for my text editor also technically, and because of both of those, the operating system is going to be Lisp. But the Lisp that I have is Lisp 1.5, which I took from the programmer's manual for Lisp. Although technically I took it from this website, which just takes it from the programmer manual. But same thing, and I have read a fair bit of the programmer manual. A fair bit is like all the important sections that talk about these functions that are part of the Lisp interpreter. Right. But Lisp 1.5 is the earliest, I believe, that we know of Lisp. By the way, technically you can write Lisp with just uppercase letters. I believe because I use case insensitive in most of my stuff, should also be able to do the same thing. By the way, yesterday I had a little mishap when I was trying to get my build system to automatically package applications and install them onto my operating system. And I ended up wiping my entire code base, including the .git folder. And I did it with RM, so I couldn't get it back. And that's why I'm cloning it again. That was a wonderful thing to have happen. There were no changes, so it was fine. But still, that was beautiful. A little whoopsie. The code that I used to package the application was supposed to work in kind of like a CI way. So it was supposed to clean the folder that it works in, but I was modifying it to work within the same folder that you're building your project in. And yeah, it ended up cleaning the entire folder, including the hidden directories. So .git was gone too. Anyway, can I do, now that I have proper modifiers, I am able to do this. Yeah, this works. Let's not. I think that's a bad idea. Doing uppercase Lisp seems like a really horrible idea. Although, to be fair, this is from the manual itself. Wait, the Lisp 1 programmer manual. This one's even older. Alright, so we have a Lisp 1.5 programmer manual from 62. Yesterday I said it was at least 1985 because it says here 1985. But no, if you look at the preface written August 17th, 1962, that means it was published probably very close to August 17th, if not on that date. And so this one, 1960. By the way, Lisp used to be considered an artificial intelligence language. So did linked lists. It's really funny to think about it that way. Since linked lists came out of artificial intelligence, they used to be an AI concept. Also, I get the feeling that this manual is just like slightly shifted. Like there's way more white space over here than over here. That's very weird. But anyway. Is it weird? Does this manual look... I was gonna say it looks very short. No, 162 pages. It's actually longer than 1.5. Anyway, not actually reading the manuals. Instead, we're moving away from Lisp 1.5. That's what I'm gonna be doing. I'm gonna be adding some quality of life features and whatnot to actually start designing a Lisp dialect. Any suggestion for learning about OS implementation? Making one. So resources, cross compiler, and QEMU. Maybe not even a cross compiler. Probably a cross compiler. You can technically use a non-cross compiler if you're targeting the same architecture, but it probably will have some subtle bugs. I do remember that happening to someone, so that is a thing. All right, so Lisp 1.5 is... I wasn't zoomed, I wasn't targeting this thing. Very, very similar to other dialects of Lisp. Actually, are there any dialects? Does anyone know if there's any dialects of Lisp that look super different from others? I don't know. I'm not that familiar with Lisp dialects, but yeah. Hello, Ninja and Snow. Why is bro called Sheldon? Why is the shell called Sheldon? Is that why they always call turtles Sheldon? Moving on. As far as I know, yeah, all Lisps kind of look the same. Really, the only major difference that I can think of is the fact that back in the day, when the language was first designed, they used to write the code in M expressions, which are these things over here. And I mentioned yesterday they look a lot closer to what C code looks like. It uses brackets, but like this pair list CADR FN XA, this thing. Actually, let's pick an easier one maybe. This thing here, EQ FN car. It uses brackets instead of parentheses, and it uses semicolons instead of commas. But besides that, it's just a function call. So this is really the biggest difference that I can think of in terms of syntax for Lisp. It used to look like this. It never really looked like this in terms of the code, I believe, but the way that it was designed is that you would write in this kind of expression called an M expression, and then it would translate into the parentheses expressions that are that it's famous for, the S expressions. Right, so this thing I would write as, well, they probably didn't consider packages back then, so let's ignore that part. This, and then this, with a semicolon to separate from the next element. Now, and that would be kind of translated, I'm assuming, with some sort of compiler, by this. Into this, I mean, which is then what the interpreter would work with. But they decided just ditch this form, just have this one. And to be fair, it makes a lot of sense because then every element in a function call is just an, well, in a function call, in a declaration, anything that you do is just a single item. Like you can have sub-expressions. Let's ignore that. Look at this list instead. What are we doing? We're building a list. What is that? It's an atom. It's a single thing, an identifier, right? Inside of the list, there's this element, single thing. It's a string, not an identifier, but still, you could have an identifier if you wanted to, and another identifier and another identifier. Syntactically, these are the same thing. They're all identifiers, and they're all one right after the other, and obviously the order of them matters, which is always the case. Same as when you call a function in C, the order of the arguments matter. You don't just put them in any order. But yeah, syntactically, this is a lot more straightforward than this. Even though this is also pretty simple. You still have only a couple of syntactical rules, but you don't need to do that. All right. So as far as I know, that's the only major syntactic difference that Lisp has ever encountered in its lifetime. However, all right, first off, let me say the limitations of the language as it is right now. As it is implemented by the original Lisp, well, 1.5, but still, the kind of original Lisp. Let me look at actual code. This is a build system declaration, so there's not a whole lot of code. But for example, here I'm defining a package. Let's ignore that part. This is a function declaration. Def. Well, I'm assuming it's supposed to be defun, define function. Is the F for def or is the F for fun? I always would misspell it like this because I would ask myself the same question. Anyway, yeah, you declare a function like this, which is a thing that I cannot do in my language. You can declare variables like this, kind of global variables, and also, yeah, global variables like this, which I also cannot do. We have conditionals, we don't have ifs. So conditionals with multiple statements. Again, in terms of looking at the code, like the physical structure of the code, I prefer to look at them and think of them as switch statements. But in reality, they're more like if-else statements in the way that they work, right? Because it's check this condition. If it's true, run this. Otherwise, go to this one, do the same thing. Go to this one, do the same thing. Go to this one, which has a true, aka if all the other ones fail, this one will always succeed because true is true, right? So it's an else. Or a switch default, right? In terms of the way that it looks, it's more similar to a switch in my opinion. In terms of the way that it works, it's closer to a if statement, because switch statements can often be optimized by like directly jumping to the correct condition, if I'm not mistaken. Something like that. I don't really remember. And trust me, the last thing I want to do is implement my compiler for an actual compiled language to go all the way down to assembly. So I'm not going to find out. Hello, Peter. Welcome. All right. Now, this here is common Lisp. And actually, this very blog that talks about the guy that created Lisp died in November 2011. Well, actually, he died in October 2011, but he wrote this in November. As a tribute to him, our exercise today is going to be to build a Lisp interpreter. And then he says, in the next page, I will give you my solution to a Lisp interpreter, which he wrote in Scheme. This has so far been my only experience with Scheme. But there is one thing, as far as I understand it at least, when I was looking at this code and kind of translating it to Common Lisp so I could run it, really the major difference that I saw was that define instead of defun, which again, how are you supposed to, is it defun? Def var, def parameter. What even is the difference between def var and def parameter? I don't remember. But one thing I do remember is that def var, you could call this multiple times, and it would only run, like, only assign the first value, which is what I wanted to do with this specific thing, the global target. I don't know if def parameter works the same way. I googled it last night. I found out def var does that. That's exactly what I needed, so I used def var here. I'm using this to be able to recompile dependencies for the project that I'm working on in the correct architecture. So def var was useful here, whereas in other places I'm used to using def parameter, but to be completely honest, I couldn't really tell you the practical difference between the two. Is DuckDuckGo gonna be smart enough to know what I'm talking about? It is. Okay, is Google smart enough to know what I'm talking about? But I have a feeling it's not. Okay, I get the same response. And it knows it's Common Lisp in the AI overview too. Sorry, Google, I have no trust in you anymore. I'm not sorry in the slightest, actually. Anyway. Def parameter always assigns a value. Def var only does it once. Okay, so literally, okay. Okay, got it. Yeah, my whole point is I only want to have to assign this one once. So I assign it in the final project that we're building. And the dependencies, even if they try to assign to the global target, they're not going to be able to. So the global target will stay the one that, you know, the final project wants to build. So all the dependencies will recompile themselves using the correct architecture. All right, so that's the difference between def var and def parameter. Maybe there's more. I couldn't really be bothered reading more. Setf is a macro which uses setq internally but has more possibilities. All right. So yeah, in terms of what I asked, that's really the only difference. That does kind of derail what I wanted to do though. Because I was looking at how to define things, and I was thinking, let me just use the word define for everything. Which would work, but this kind of nuance between the difference of parameter and var, we would lose that, for example. Which means at the very least I would have to change my my build system. Besides translating the entire thing, obviously, I would have to make a difference between def var and def parameter. To be fair, I don't really have to. Only limit it to once. But right, the code is here. The code is here. Right, when I was working on the Lisp interpreter according to the Lisp programmer manual, I came across label, which is a special kind of expression that allows you to take a lambda, which is an anonymous function, and give it a name. That way, it can reference itself. And you say that you have an anonymous function and you give it a name, that's just a function, right? So this is how you define functions. It's actually more limited than that. In the sense that if I try to use the function, the function is called fib, it does Fibonacci sequence, and it's used within itself, right? For any number that isn't 0, 1, or 2, it will try to add the two previous numbers together. So it's a recursive function. And thanks to label, it can call itself. But it cannot be called from outside of this outermost scope here. You cannot call it there. I'm not sure what the plan was there. I'm completely different code base right now. All right, it says symbol not found because the symbol does not actually exist. You can label it that this lambda is called fib, and it can call itself by calling fib within itself, but it will only exist within here. The point is label will do that, and then it will immediately call the function. It will immediately apply the function using whatever parameters you're passing here. That's what the 6 does. Yeah, that's cool. Is it super useful in modern Lisp? I couldn't tell you. But you know what is useful in modern Lisp? Proper functions. So I want to include a define, a proper define. Is Lisp functional programming? It can do functional programming, yes. It inspired a whole concept of functional programming, but it isn't explicitly made to be a functional programming language. But because it works on lists natively, very similar to functional programming. I think functional programming was inspired by Lisp. And by the way, before I discovered how amazing Lisp is, my plan for scripting the terminal was going to be a functional programming language. Information processing language is sometimes cited as the first computer-based functional programming language. Okay, so it got beat, but it actually got inspired by IPL, so it makes sense. Then APL. We looked at APL yesterday. Mother of God, this is what ET was using to program. This language is ridiculous. It's gibberish. I look at that and I think, oh, the file got corrupted. Is Lisp amazing? It is amazing, yes. Any coffee? Can I get someone else some hot brown liquid? Hold on, say less. Cool thing about cold brew is that in this fucking weather it stays hot for cold for like 2 minutes. But hey, at least it's cold now. Way ahead of you on getting the coffee. Way ahead of you. Can programming be liberated from the von Neumann style? The answer was no, by the way. Although, yeah, it's funny. Functional programming is very, very separate from other computer programming paradigms because it was meant to be completely different. It was meant to be a completely different type of computation. Right? If I'm not mistaken, it actually derived from lambda calculus, which is supposed to be an alternative to... Is it an alternative to Turing machines? Am I wrong about that? Is a universal machine a model of computation that can be used to simulate any Turing machine and vice versa? But if I'm not mistaken, it often gets presented as an alternative. If somebody knows about it, please correct me. or confirm what I'm saying. I have no idea, but I do know that it derived from this. Now, let's see what Lisp gets mentioned. There it is. In the 1970s, Guy L. Steele and Gerald J. I still cannot get over every time this guy's name comes up. His name is Guy L. Steele. That is the coolest fucking name ever. He sounds like an action movie hero, not a computer programmer. Guy was jumping off of planes. In his spare time, then he was just grabbing a laptop and starting to code. There were not even laptops in the 1970s. Didn't matter. The guy had one. And by the guy, I mean Guy. So he developed Scheme alongside Gerald J. Sussman and described in the Lambda Papers. That is an interesting name. And this beautiful book. And Scheme was the first dialect of Lisp to use the lexical scoping and to require tail call optimization, features that encourage functional programming. So again, I do think you can do functional programming in most Lisps nowadays. I definitely want to do it in mine. But it wasn't made for that, necessarily. Although, you know, the whole lambda calculus thing, like, is very much derived from that, if I'm not mistaken. Here's the thing. Back in the 1960s and 50s, programming was mostly done by mathematicians. Because, like, a few decades before, there were no programmers, there were no computers. So the closest thing they had to somebody who knew what to do with the damn binary machine was mathematicians. And they brought their little way of doing things to programming, for good and for bad. Lisp being the good, not saying what's the bad, nothing in particular. It's -1 degrees. Damn, where is that? I need to move. Yeah, no, not saying what's the good and what's the bad. Just, I'm bored, so I'm scrolling through Google images, as you do when you're bored. That's it. Anyway. The lazy functional language Miranda. What does it mean, the lazy functional language? And then, you know, I don't know what Haskell looks like, actually. Code examples. Right. I have to say, it's not very beautiful. I look at functional programming languages and I think they're quite beautiful. This is not. What is Devopedia? I'd never heard of Devopedia before. Anyway, functional. Wait, hold on. I have examples of functional programming that I can show. I've written 2 or 3 different, the same code in 2 or 3 different examples, if I'm not mistaken. COBOL, the original functional programming language, in that it functions. No other way. It has functionality. That's what I mean. We got Gleam. Seem to remember something really ridiculous about this language. Right. You have to import all these packages. Just to use an integer, you have to import a package. And the package is lowercase, but then the int type is uppercase. And this was very ridiculous. I had to do a Haskell computing course last semester. It's so bad. Is it really bad? Shall I find a Haskell interpreter and write this thing in that? I'm probably gonna do that. Screw it. All right. Oh, I have to say I don't like doing this anymore. All right, the code that I'm trying to write is iterating over this using an accumulator, which in functional programming is just reduce to use an accumulator. And based on these characters, it will add 1 to the accumulator, multiply it by 2, remove 1, divide it by 2, or multiply it by itself. Anything else will not modify it. All right. Let's find out how to reduce. Fold. All right. So first off, we're gonna have a string. There's no syntax highlighting, which is very weird. We're gonna have a string of plus, plus, times, minus, divide, and this. I probably got it wrong. Plus, plus, times this thing, minus, and divide. I got it almost right. All right. So we're gonna go over this thing, and we're gonna want to reduce it. So fold it. A string is a type of char array. That's good. I was hoping for. Hey Malifas, how you doing? Welcome back. Folder or fold L? Oh. Did that show them? Oh yeah, foldle or folder. Alright. So L means left to right, and R means right to left, correct? I can assume I can hope that that's how it works. Alright. I was a little bit confused as to why I was looking at Lisp. But folds in other languages. Why is this in the Haskell wiki? You say you could have done it if you were using a different language. Alright. So how do I declare the function that I want to use to fold? Are we against syntax highlighting, by the way? This is the Haskell wiki. It's so hard to tell what's what when you don't know the language. Anyway. In and out of hospital. Oh, sorry to hear that. Well, now that you're out, welcome. Foldle is left associative and folder is right. Yeah, I think. Alright, so is that how it. No, 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 hold on. Come to think of it, isn't fold usually something. Doesn't it use like two parameters? The initial value and then the. Okay, without a syntax highlighter, it's getting really hard for me to tell what's syntax, what's explanation, and what is going on. So I am genuinely lost as to what is syntax, or why the syntax seems to change every time I open a different page of Haskell. This is this is confusing. Folder fn start value and list. Okay, that explains it. Again, if I could understand this through... There's also fold I, fold T? Oh, tree-like folds. Okay, I went way too far. Alright, okay, so Z is the initial value, which is why if the list is empty, Z gets returned. Okay, apply the result is the initial value Z. Else apply F to the list, to the first element, and the result of folding the rest. I still cannot understand what's code and what isn't, and neither of these things has a syntax highlighter, which makes it so hard to understand. Is this actually part of the syntax, or are you just explaining it? It doesn't feel like it's just part of the syntax, but then I read this, and it feels like it's part of the syntax. It's telling me, in the case that the list is empty, return the initial value. No, I get that this is a comment, so that must mean that everything else is not a comment, right? Does sed by any chance have a syntax highlighter for Haskell? Doesn't have a syntax highlighter for anything, man. Folds are just reduced, right? I understand that. If the list is empty, the result is the initial value. Else, we recurse immediately, making the initial value the result of combining the old initial value with the first element. Got it. Reduces are a type of fold. That is new. Okay. I have to say I'm so confused, but at least this has a syntax highlighter. Hopefully this will help. Alright, wait, hold on. The link, I'm pretty sure was supposed to be the specific section, so let me... There we go. Write associative fold of a structure, lazy in the accumulator. In the case of lists, folder is, when applied to binary, no, that's not the problem. Okay, since the head of the resulting expression is produced by an application of the operator of the first element of the list given an operator lazy in its right argument. Oh my god, they talk like mathematicians. This is annoying. Give me examples. Alright, basic usage. Folder, okay, this is the function. Initial value false. Sequence is false, true, false. Will of course return true because we're doing an OR between these three values. So far so good. Empty, false, makes sense. Returns an initial value. Okay. This one actually seems like what I'm trying to do, so it might be helpful. Initial value foo, and what the fold is gonna do is it's going to, not sure what this syntax is supposed to mean, like this thing is supposed to mean. Is it specifying that the accumulator is a character? Takes the accumulator plus plus C. Alright, let me try to run this and fully understand, right? But reading code is not what we're here for. Alright, so first off, can I do this? Right, I'm not using random letters, I'm using symbols, but it should still run. Except I didn't do it right. Okay. So most likely I do need to do this. String is simply a synonym for char array. Well, it doesn't feel like it. Unless that code just doesn't compile for some reason. Oh, is it because I put it in main? No. Main do. Thank you. Am I supposed to keep it on the same line? Couldn't match expected type IOT0 with actual type char array. When checking the type... Okay, it wants the result for main, right? That's the problem. Return at the end. Just saw that. Nah, that's not helpful. Okay, hold on. Let me just copy what I have real quick. Just go back to the original version of this. And they were just doing a put. Alright. Best to put main IO before defining main. Return on a separate line after your code. Alright. Probably the do also on a separate line. It's not indent aware, is it? Returns an IO. So do I have to do that? Well, right now we're just doing a little dance to appease the compiler gods, mind you. It is indent aware. Fuck right off. Anyway. Love the thumbnail meme. Nice. Welcome. Alright, hold on. Haskell main funzione. So I don't have to do a return like that. Alright, at the end of the day, I do need to do, like, let result, and then I do need to print the result, and I saw them doing that, so can I just do that? I feel like we're getting there. Possibly incorrect indentation or mismatched brackets. Well, that does look like incorrect indentation. So where do I put it? Oh, I forgot that. Oh, there we have it. Okay. Oh, we did it. We did it. The ritual appeased the gods. Cool. Okay. So, that confirms what I want is fold L. It's different than fold R, isn't it? So different that they're not interchangeable. It was literally right next to the other thing. Can I just... right here. Left associative fold of a structure, lazy in the accumulator, stays the same. Okay, examples. Alright, I have to admit, I don't understand how changing it to fold L has broken it completely. This is rarely what you want? Here? Oh, I see. When it comes to lists, you always want to use either fold L with an apostrophe for some reason. First paragraph, second sentence. This is rarely what you want, but can work well for structures with efficient right to left sequencing and an operator. Okay, but I want to go through my string left to right. Right? Is that crazy? I don't understand how that's not what I want. This is going through it backwards. Like, this is how I'm doing the fold. And it's supposed to go through it left to right. Initial value 0. You're trying to append one string to another. No, the actual function that I'm using here is not relevant. I copied that. What I want to do is this. What I want to do is take the character and based on the character perform a different operation on the accumulator, which is adding, removing, multiplying, dividing, or multiplying by itself. That's what I'm trying to do. But again, I'm supposed to go through it left to right. I don't understand why this is something that you rarely want. That is a very weird thing, because this is going through it backwards. Unless the way that the code works is different than I expect, but I don't think it is. Recursion is probably easier. But why would I need recursion? This is how I've done it in literally any other functional programming that I've used. This is not a recursive function. Even in Lisp, I didn't do it recursively. I use reduce. It's just a reasonable thing to do. Which, by the way, now that I know more Lisp, I could not have this whole thing and just have a condition. But it's only fair that I write this code in my own language, by the way. Not sure how I can make my language process characters individually, though. A lot of set theory. Oh my god, I might give up on this. Let me be so for real right now. Why am I doing this? There's literally nobody forcing me to do this. This is not even what the stream is about today. Alright, I'm gonna keep this open. Just in case. You want to try it for fun? Alright, so the original code is... What language do you want? I literally have it in all of these languages. But the original code in the best programming language ever, Swift... well, the best syntax for a programming language. The compiler is deeply flawed. Anyway, you have a program that... By the way, this comes from the Odin website. So if you want it, it's from the Odin website. It's this thing here. You have a program with plus, plus, multiply. I chose the this symbol, whereas he chose an emoji, just to show that they have emojis. Subtract and divide, and you have an accumulator with 0. You go through the string, and with each of these you perform a different operation. Plus 1 times 2, multiply by itself, minus 1 divided by 2. Ignore everything else. Right, so this is the code. There it is. Trying to port code from a language you've never seen before. It's a very simple to understand code at the end of the day. If you've programmed in any procedural language, you understand this code, I'm pretty sure. If you've only coded in functional programming languages, then yeah, I can't say I've done a whole lot of very pretty ones, but this is how I did it in Swift. Again, same thing, reduce. Initial value 0. Then just take it and return initial plus 1 times 2 minus 1 divided by 2 times itself, default value by default. Lisp did the same thing, though I could do it with a conditional, which makes more sense. Where actually this makes it a lot cleaner, but it's the same code. Oops, forgot the parentheses here. And then true, return A. And there we go, that's a lot cleaner. Could do the same thing here, can't really be bothered. I also did the non-functional version. Alright. Tell me this isn't a lot cleaner though. Mind you, I could put it in a lambda. Just have a lambda here. If that's how you want to do it. Ah, my first ever Lisp. It's been so long. It's been so nice. It's been a month. Maybe. I don't remember exactly when it was, but it's been about a month. Alright, I still don't understand why you wouldn't want to do left to right, when that's literally how you do everything in computer programming. Mathematicians. They certainly don't like to do it the easy way. I'll give them that. Alright, if you do get some Haskell code, I would be very interested in seeing it. We do not. Yeah, that's correct. Alright, unfortunately, I will not be able to write this code in my own Lisp yet, because I do not have this, as well as not having reduce, but we could make reduce eventually. Alright, I want to make my scripting, actually I have more. I do want to make my scripting functional. I do think that functional programming is very, very useful when it comes to the terminal. For example, pipes really remind me of this kind of thing that I've seen a few programming languages do, which is that you take a value and you pass it as the first argument to the next function, which is this one. This is the equivalent of doing string to graphemes and taking this string as an argument. Then taking this whole thing as the first argument of this fold. So very similar to what pipes do. I mean, think about it that way, suddenly makes a lot of sense to have functional programming in the terminal. Also the fact that a lot of things that you want to do is like data manipulation. Yeah, functional programming is great for that. This is probably what you wanted. In the code that I was writing, probably the output of the program, like the actual number. Oops. Yeah. Can I go back? I see, it's accumulator first, then C. Not C, then accumulator. Okay. I see. I see. Okay, So let's now I have renewed interest in this thing. Haskell switch car. Switch is not probably gonna be like that, but no, switch is not what I'm looking for. Hold on. All right, conditionals. How do you do them? If to bool p, okay. Guards. Guards. Well, this is comparing guards, if, then, else, and cases, so maybe. If, then, else. Case mapping off constant and function. Isn't case what I want? Like, that's how I wrote it here. And then guard complements case of expressions, meaning that if you need to make complicated decisions depending on the value, first make decisions depending on the structure of your input and then make decisions on the value in the structure. Where are you using guard? There's handle, which is what I'm assuming they mean. So I'm pretty sure that's probably where Swift got its guards from, which I don't have any here. But it's just a if style of thing used for early returns. You know, guard condition is true, otherwise return with an error, probably. That's how Swift does it. Anyway, I think what I want is case, then. Alright, based on case of C? Can I put indentations here? Can I do that? I'm not sure I can do that. Different definitions? I don't get what that means. I mean, my idea of doing it would be like this. Where the accumulator is actually a value like this. And then, is there a case default? Oh, case. Underscore, thank you. Guard. Okay, so yeah, guard works kind of like an early return type of thing, I believe. Anyway, so for the underscore, I just want to return the accumulator, right? Is that possibly incorrect indentation or mismatched brackets? It irks me when a programming language tells me about indentation. If Lisp did that, it would go from the best interpreted programming language to the worst. Because Lisp does have a lot of parentheses, and the main thing that makes them manageable is the fact that I can indent them, like this. Although, you know, when you learn to write it properly, instead of using this, you learn cond, becomes a lot cleaner. But still, you end up with a lot of parentheses, so indenting is very important, but I choose the indentation. This is not it. Indent-aware programming languages are not the thing. Is there an auto format on this thing, maybe? No, there isn't. That's it's very annoying. All right, so you don't want that. What do you want? Why am I trying to do Haskell? Did you read my mind? I. All right, I'll come back to this later. I don't. Nah. This is just gonna give me a headache. Anyway, back to Lisp, an actually good programming language. All right, so what was I saying? Right, I was talking about label, which allows me to give an anonymous function a name, therefore making it no longer anonymous, but only within the scope. Now, could you technically define functions in this manner? I'm going to think yes, probably, but that's not how you usually do things. So instead, I want to introduce a define, right? Where you define fib, you define not a lambda. Ideally, we can get rid of the lambda form of it, but not necessarily immediately. And then, most importantly, get rid of this. We're not calling the function, we're just defining it, we're just creating the function. And if I'm not mistaken, the reason that I'm also not getting rid of the lambda is that I already have the code for handling a define. I just didn't want to put it in because so far it's been Lisp 1.5. Now I'm actually developing my own thing. Although I do realize it has changed. It has changed since I wrote that code. But it should be pretty much this. All right. Right, no, it hasn't even changed. I just move it from eval to apply, so it's a different function. All right, so what this is going to do, what define is going to do, is it's going to take the name of the function that you're defining, and it is going to take the value of the function that you're defining, essentially the whole lambda, and it's going to associate them with each other in the environment, which is actually just a linked list itself. So inside of that linked list, we will have an entry that looks like this, with the whole lambda in here, followed by more entries with more things that are defined, which can be empty. Right, but so that means we need to take the see, I find this code a lot easier to visualize if I indent it instead of having it in one line. The fact that I couldn't do this in an indent-aware language is ridiculous. All right, so the first thing I need to do is I need to get the first argument of the define function, which I do by doing cdr, which is everything except for the first thing, right? Our function looks like this: define, the name of the function, the lambda, which I'm just gonna write as L for now, and then that's it. Actually, that's all there is. Const, car, and cdr. So that's exactly what I'm gonna explain. So this is considered to be a list, right? Again, the cool thing about using S expressions, literally the word define, the word that actually gives the function definition, and the lambda itself is a sub-expression, but let's imagine that it's a variable called L. they're literally all the same thing. They're just a linked list that contains these three elements. Right, so that linked list is the expression that we got passed into this function. The first thing we did is check this function's car, which is the first element of the list. Car stands for... Actually, yesterday I couldn't really remember. It's a name of a register from the original machine that they wrote Lisp for. It actually stands for John McCarthy. And of course his middle name was John McCarthy. So that's where the CDR comes from. That's where that's what those names mean. Contents of the address part of the register number and contents of the decrement part of the register number. Right, so essentially, this is just from the assembly of the machine that they used it to build the original Lisp, but car is the head of the list, CDR is the rest of the list, the tail, if you will. So when this is the expression that we have, we're going to take the tail and then the car of that, which is the first element. Essentially, we're taking the name of the function. That's what this is doing, except the variable here is wrong. And then what is its value? It's going to be this thing. So we have to do CDR, right? So from the whole list, the rest of the list without the first element, the rest of that list without the first element, the first element, because it's technically inside of a list. So we get the first element of that. That is to say, our lambda. And cons is constructing a list out of two elements. So we're doing this pretty much. And then we're taking this and we're putting it inside of the environment by constructing a new environment using the existing environment and this thing at the beginning of the list. I don't happen to have any DWC2 resources. I did write a DWC2 driver, so my code has some. The resources though, how did I learn to do it? Not sure I remember if I found any kind of... I don't remember actually finding any resources for it. I mean, I did. You fix your Minesweeper thumbnail, there's a one with no bombs around it. YouTube Studio is not loading thumbnails, so... Classic. YouTube Studio never works on weekends. That's not true, necessarily. There might be a bomb up, but you are right. Found some unofficial piece together things, but it's a bit obscure. That sounds about right, yeah. The thing is, I already had an XHCI driver, which I found a great resource for. So I learned how to do USB with that. And then DWC2 is similar, simpler even. So it wasn't as hard to do. Actually, a lot of the code is shared between the two. Like the overall way that they work is shared between the two, just works. The actual way of communicating with the device is different. All right, so the logic for this should be correct. We are modifying the current environment by adding a construction of the current environment and a construction itself of the name of the function that we're defining and the lambda that we're using to define it. And we're actually modifying it. Since this is a pointer, it should work. Code is complete. All right, give me a second. Let me see if this works. It works. Okay, that's good. All right, I'll look at that in a second. Now I have I have function definitions in the sense that I have the name of the function, which is, again, the first element that I'm getting. I'm getting from this whole thing is a list. So I do car to find the define, right? I match the car, the first element, the head of the list, against the word define, and that's how I know, oh, this is a definition. Okay. Then I do CDR and I get the rest of the list. I get car from that, which is the first element, that's the name of my function. I do CDR from that, which is the rest of the list. And I do car from that, which, since it's the only element, is the same thing when we look at it this way, to get the lambda. And I take the name and the lambda, I put them together, and attach them to the environment. Thus, I am able to use them outside. Now, the interesting thing about the define is that it doesn't really produce anything. So this is the result. This is the result of this thing, which is first element. I use the dot to separate between first and second elements of the list. When I'm debugging, makes it a lot easier to see null values because it's literally empty. Right, so this here, which is literally empty, is the result of this expression. It modified the environment, but it didn't do anything. It didn't actually produce a result. And then the actual result here, and then null terminated. All right, so that worked. Let me look at Haskell. Okay, your result is 7, so that is correct. Let me see. You're using printf and data list fold L. All right, text string, it's this thing over here. All right, then operate int to char to int. Am I reading that correct? Operate x plus, then add x and plus. X plus 1. Do the same thing for all the other ones. So, okay. All right, you use this symbol to mean multiply by itself. And then do nothing means just return the original value. And then the actual function that you're doing is operate. Okay, so the word operate is not a keyword. It's just the name of the function. Am I reading that correct? The name of the function, starting with 0, using the text. Holy, okay, now I like it. I like that. The pattern matching is very interesting. You know, I'm glad that I gave up and you gave me this, because if I had done it, I probably wouldn't have done it like this. And here's a little spoiler for these days. I was designing a pattern matching system to replace regular expressions. Works the same as regular expressions, but the way that you write them as the programmer is different. Which... oh, I never saved to this computer. Whoops. But yeah, it was supposed to be pattern matching. Somewhat similar to this. I showed it a while ago, I just don't have it on this computer anymore. But I do have it on this one, I believe. I can at least copy it. Yeah, it was going to be something like this. Yeah, friends, whatever. Multiple friends. where essentially it's just matching this whole literal string followed by either this literal string or this literal string, and captures whichever one it is. And then when it gets matched, it runs this code. So maybe I want to look at the pattern matching that Haskell is doing, because that's interesting. Another language that I wanted to look at is awk, which is where I got the overall syntax from. Regular expression pattern, run this in the event that the record matches the above regex pattern. So that, but instead of using regular expressions, something a little bit cleaner like this. Even though it's longer, it's cleaner. Just regular expressions can be... Well, actually, this one would be very simple. Mind you, I didn't even put in a space in this example, so... You could do it like this, but regular expressions can get incredibly complex and ugly to look at. I actually found out about this recently. When it comes to regular expressions. Turns out you need a license for regular expressions. It's really good when you approach patterns from a mathy direction, but otherwise I recommend awk. Yeah, I'm talking about text-based pattern matching. Hello, iSteve. And hello, Profile. Right now I'm looking at something completely unrelated, but I'm working on a scripting language for my terminal. That's what I'm doing. Licensing regular expressions, because you shouldn't be adding regular expressions to a code base without a license. You know, when I first stumbled onto this, I was like, wait, are they licensed? Do you actually need a license? Do you have to care about the license? But no, it's just a joke. Okay, I'm getting to the part of the coffee that filter is not very good, I have to say. There's a lot of like ground coffee on the bottom of this thing. Alright. Done with the coffee. This interesting idea for undoing in editors today. Let me see. Hold up. Tree form. Hey. Interesting. What's happening? Alright. I guess X cancelled is cancelled. We're gonna have to look at this one. Editors undo graph visualization. Tree-based. I thought actually he was showing off like something that he was working with involving graphs. I didn't realize that was the visualization of the editor. That is super cool. Hasn't posted. The friendly editor. The Freditor. Nice name. X cancel is just a way, it's supposed to be a way to access Twitter without using their website. Because it's one of those that, you know, at any point will ask you to log in. And also if you don't want to give them the traffic. Although they're still accessing it for you, so big deal. But yeah, because it always requires an account and it gets really pedantic. It does so less so now that I actually have a fucking account again. But there was a time in which you couldn't see anything on Twitter that was if you weren't logged in. Not showing off a lot here. Why does it look like VS Code, by the way? The colors, these are very default VS Code. Alright, I want to look at this a little bit later. What's the slop name for X? Like microslop for MS? X. X is the slop name. Twitter is the real name. Alright, so I have function definitions now in my language, thanks to this. That already allows me to do a lot of things. Very, very convenient. And I have a variable definition as well, technically. I can define anything I want. Just, again, first argument of define, the thing that you're going to be defining. The name, a second argument, the value of the thing that you're going to be defining. Although this should work. Let me see if it works. It does. But again, we have yet another define now that doesn't produce a result. So it's result of the define, result of the define, result of the operation, null termination. Right, so the printer looks like that. Big deal. It works though. Video at 9:34. Why didn't it work correctly? Because it's YouTube. YouTube doesn't work correctly. Alright, we'll look at this in a minute. Well, probably more than a minute. Let's be clear. Now, here's the thing. Here's the interesting thing. At the beginning, I said I want to do like I believe scheme does and just use the word define to define anything. But how do I differentiate between defining a function and defining a value, a variable at all? Because right now I have to explicitly use a lambda. So again, what I'm doing here is taking anonymous function and giving it a name. That's how I'm defining functions. So that's kind of ugly, sure. But if I get rid of the lambda stuff, right, and I just leave the parameters, that's how you differentiate. That's how you differentiate. Right, but how do you know if this is the arguments of the function or just the first expression to validate, to initialize your variable? That would be weird. So probably better to define them separately. Maybe Common Lisp was onto something. Now, scheme function definition. I haven't actually written scheme. Like I said, my only exposure to scheme has been when this guy here wrote the solution to their Lisp interpreter in scheme. It's defined. All right. What about a skill? No, a scheme. A variable. Let's call it parameter definition. Because there's another way of doing variables which is like very heavily scoped. Parameters are usually not scoped. I don't think this is what I was looking for. Why does Lisp have so many brackets? You mean parentheses? Because everything is the same type of expression. It has like two syntactical elements, pretty much. The S expression, which is one of these things with parentheses, and an atom, which is one of these things without parentheses. That simplicity is just unparalleled. Alright, let's see an introduction to scheme. You're going to find new procedures with define. You're going to find variables with define. I see. Alright, so the way that scheme does the differentiation between whether it's a function or whether it is a variable is, can you, okay, essentially that you would do it like this, define fib n, and then here the code. Whereas here you would not have it like that. So I would have to check the second parameter. If it is a an atomic expression, then I know that it's a variable, and I have to evaluate the rest, because that's the question I was going to ask myself, right? Because I can define things like this, and the value of a should be 7, not this expression. It's not a macro, it is an actual expression. What if instead of n, it was another expression though? Yeah, I'm not sure, but at least I understand, like maybe you can do it like this. But I don't like it. I don't like that necessarily. Whereas in common Lisp, you do defun, fib, a, b, c, these are arguments, and then body of the function, which is easy to access, right? But the word is different. And then for parameters, you do def var or def param, well, a, 6. But because you know that these are different words, they handle it completely different. Defun would mean to remove some fun from something. Sounds about right, yeah. A while ago, somebody mentioned also a different language. Another... It was something with a J. I want to say Julia, but no, Julia is a different language. I'm talking about a Lisp. I closed it? Janet. Okay, it was Janet. It was Janet, which is a functional imperative programming language, but it is a Lisp as well. So they do defn, def. And by the way, the main way to define variables is let, where they only exist within this. But that's not what I'm talking about. I'm talking about parameters. I'm talking about globals, essentially. What's the ETA? ETA for what? Right now I'm working on scripting for a terminal and code editor for the operating system. All of which are technically things that are always evolving. So it's hard to answer. But the OS is finally starting to come together with all the features that I wanted to have. So it's looking good, I can say that much. I do think I'm going to meet my deadline of, by the end of the year, be able to code entirely within it. Alright, so to define a function, you have this, you have this, you have brackets, brackets, brother, brackets. Get out of here. Alright. What about define? Is that a valid scheme? Hold on. Reading code from the chat can be so hard, so I'm just gonna copy it. What is that supposed to mean, though? Everything low level in C and then higher level CPP? No, everything low level in C and higher level C also. CPP is there. It is an unfortunate mistake that I made. And it's useful for inheritance in some places, but even now I've replaced like the way that I was doing things. I don't even need inheritance anymore. And it really just gets in my way because it tries to be a high-level and low-level programming language, and it fails at both. So no, everything, everything should be C. Unfortunately, I made mistakes in my youth, and I used some CPP. Of which there is less and less, because I'm literally like eliminating it as much as I can. Sometimes I just get angry. Whenever I find a bug in a C++ part of the code base, I just go like, okay, fuck it. Next 30 minutes, I'm going to rewrite it in C. And yeah, it's pretty simple. It doesn't make the OS slower, technically, not to any significant level anyway. Technically, sure it does, but like, any choice that I make as the programmer is way more likely to impact the speed than C++ as a language is. It's not slow, by any means. It just has hidden complexity, which is ridiculous. It's not worth it. It's not worth it at all. Your car reported what? 52 Celsius and 54 Celsius. Jesus. That's not what like the bus stops over here report. Then again, that's because they probably have sensors in the bus stop which aren't super accurate and also being hit with the sun directly for hours on end. But shit, does that really matter when you're sitting on it? When the bus takes 20 minutes to arrive? No. Alright, so I have to decide, do I want to have different definitions for things? I think it's the best way. I think it's the best way to do it because I don't want to have ambiguity. There should not be any ambiguity. And for example, what if, real quick, I am testing my function, right? Something like this. I'm testing my function and I just wanted to return a static value, always 0. What's the difference now between a function and a parameter? In reality, none. Sure. But like, yeah, nah. Here I can do this. By the way, that. And these are parameters. I could even use the words function and var without def. Just function, fib, var, maybe fun fib. And I do want the difference between a variable and a parameter. Although I have to say, I may switch the meaning from how common Lisp does it. This is literally something that I found out yesterday, right? But var and par is what I was going for. Par is not super. It's not a great name. Fun is not a great name, but so many languages do it that like I highly doubt someone's first exposure to programming is going to be this Lisp language. But anyway, par is a little bit less understandable. But anyway, a parameter in Common Lisp, you can assign to it as many times as you want. You can define it, like def parameter, a1, and these are going to run sequentially. The value of a is going to be 2. If instead of parameter though I use var, the value of a is going to be set once, and this one will not do anything. Which I'm using in my build system for being able to tell every dependency that is compiled with Lisp to only set itself once, right? So the outermost program, actually that's the way that it works for my code editor. The code editor calls this function set global target redacted. I can change this to Linux. Then it tells the compiler, which is the one that has the interpreter, and the UI library to recompile themselves. And they will use the global target set here. If they try to set the global target again, they will not be able to. It will always be this one, the first one that was set. And since the entry point to the entire thing is, what did I do? The entry point to the entire thing is up here, then the first place that it gets set is here. Isn't that just a constant and not a variable? It's not a constant. It is a single assignment value. But you are right that var stands for variable, and that is not var. So yeah, maybe const is a better word. All right, so this is the definition that we're doing, right? A is 7. This is gonna be B. B is 6. That only once. I did not write 6, 7 on purpose. That's super dead now. I hope. Anyway. By the way, I just mentioned like 10, 15 minutes ago, I was talking about pattern matching in Haskell, pattern matching in awk. Is that how you pronounce it, by the way? A as in fraud, and k as in kind. So awk, yes. I was talking about pattern matching in awk, and I was talking about wanting to make a text processing language similar to what awk does, except not using regular expressions directly, but just like making them a little bit longer, but easier to parse once you read them, because irregular expressions can get incredibly ridiculous. There's one regular expression in the operating system right now. In the manual. To kind of auto-summarize a manual for you, we use this regular expression. Look at this monstrosity. You know what it matches? It matches a markdown link with exclamation point in front of it. Irregular expressions. I like that. So yeah, I was talking on making this text processing language, and I was waiting until I do that to rewrite the tokenizer that my compiler uses. So I haven't touched it since, but there's one thing that's really been bothering me here, and it's the absolutely cursed, ridiculous, fucking insane comments in my Lisp. They are C comments. Mind you, this is entirely my fault too, because I could have used this symbol as well. I could have used this symbol, but this symbol is actually used by some Lisps, so yeah. But anyway, I am going to modify the tokenizer and add a semicolon comments, because this is ridiculous. It's gonna get ridiculous if I just keep going like this. It's going to break me. However, we will not have proper identifiers. You can get pretty crazy with the names of stuff that you do in a Lisp. Like, I believe this is a convention, at least someone told me that it was a convention, that you set global variables with this symbol. Even though I don't like it, I have been following this convention that, again, somebody just told me that this was the case. I don't know if it's true. But anyway, you can do this. This is a valid identifier in Lisp, but not in C. And I'm using a C tokenizer, which is also why my comments look like that. That part I'm not going to touch yet. That part will encourage me to make this whole text processing language. So until that's done, I will not have these kinds of names, but I cannot have those comments anymore. Tokenizer. All right. Tokenizer. Comment type semi. Alright, and I'm pretty sure I will then need to specify this thing for it. And we're gonna do this. And this is the correct library. Very good. So we're gonna go into here. And in the place where I set up the tokenizer, type semi. And get rid of this, finally. Fuck! That didn't work. Purely as a matter of convention, all global variables used by Common Lisp have names beginning and ending with an asterisk. Yeah, I don't like it, but yeah, somebody told me. Now you're confirming it. Although it is a French link. But you are confirming it. Now, what are we complaining about? Expected string found semicolon. So I guess there's a little bit more setup than I needed to do somewhere, somehow, that I didn't do. No, not semi. The other one I want to look up. Hash. It's not used anywhere else. Is the symbol used anywhere else? No. That's not what I meant, but the link is in French. Typical that the French would choose asterisk. The link is French, the convention is not. I am recompiling. Well, yeah, otherwise I would have gotten an error. Worth making sure. I am not recompiling. I am not recompiling. Because the text editor recompiles the library. The compiler does not. Expected string found. Okay, period. That's good. On line 15. Yep. Okay. And now I added all of these ridiculous functions, which, by the way, it complains about them not existing. Which is true. And they all result in null expressions. This is the final result of my entire compilation. A bunch of null expressions with a 5 at the end. And then this cursed little thing over here. Anyway, yeah, we're gonna get rid of this. Okay, so I've decided I'm going to do variables with var, const, set them once, only once. Oh, I don't think I'm actually using them anymore. I was originally going to use a constant value, and then I ended up not using it, I believe. I'm not entirely sure. How hard is it to make an OS? That depends on what you're making. Something very basic can be simple. Or something can be very complex. It's a very broad type of question. Then again, it entirely depends on your scope, on what you want to do. Okay, so yeah, instead of define, we're going to have var, fun, const, also macro. Macro, which is going to be similar to function. But its result is going to be put in place of where the macro is used. Is there more to it? Probably. There's probably some more to it. We're not going to deal with macros yet. Oh, I can finally do this. I can finally do this. Oh my god, that is so... that is such a relief. That is such a relief. Alright, so we're not going to have macros yet. Instead, we're going to have var fun const and not define. So our function fib is going to take a variable n, and it is going to take this thing and go like that, where that is the body of the condition. This is the body of the function. All right. So get rid of that. And now this will not run because it won't find the symbol fib. So we have nothing here. Def instead of const. Meh. I don't know. It was an American CS guy. Guy Elstein. I was just praising. Every time I hear that guy's name, I have to praise it because it's such a cool name. Wait, was he junior? Or is that like his son? Hold on, this guy L Steel is... He's getting more and more... He's junior. He's a junior. Wow, his name just keeps getting cooler. Holy shit. Imagine being named Guy, your last name is Steel, and you're also a junior. Oh please, Guy Steele was my father. Call me Guy L. Steele, Jr. Just con... Oh, because you want the 3-letter. So what's macro? Mac? As much as I wanted to keep it 3-letter, con would be a little bit too close to cons. Which, mind you, so is const. But, nah. Because there is also cons, sorry, which, like I said before, combines 2 elements. Macro and const are both 5. Var and fun are 3, so you have consistency. Alright. Alright, I like it. I like that. Yeah. Alright. You're good. No, you're not good. I'm good. There's let also, which we don't have yet, but yeah, we'll be adding at some point as well. Let declares a variable only within its own scope. But anyway, so you're not define anymore. Actually, you're not anything anymore. We can begin with var and const. For now, I'm going to make them match, have the same behavior. Since I'm not using const, to do const should only assign once. Actually, it's not super complicated. You just have to check the environment to check if something exists, and if it does, not do anything. Which is really just as simple to do as just taking the name of the expression, right? Which is this one. This is the name of our expression. And exists, do a search for it in the environment. And if this whole thing exists pointer and that, so if exists is not null, then we just return a nil expression. That is to say, we didn't actually assign anything to the value. All right. In any other case, we do assign it. All right, so let's see if that works. So var and const should work now. We're gonna get rid of this. Boom. Look how easy. Look how easy. All right, and we should be able to just do A and B. Okay, A is 7 and B is 6. That works. That works. const gets assigned once, checks if it exists. It doesn't, so it assigns. If it already exists, as is the case for the second one, doesn't assign. Easy. Simple. Just flip them around, both are 7. Cool. Cool. Alright, so var and const are already there. Alright, there's an add starting, so I'm going to do function, which we technically already had, and then I broke it apart, because, well, yeah, that makes sense. So I'm going to do that in 3 minutes. I'll be right back. Okay, here we are. My mouse pointer is the right size today. Yesterday, through absolutely no configuration change on my part, between yesterday or today, the mouse cursor on this monitor was really, really tiny. Today it's perfect. Linux jank. What can I say? I believe this one we can blame on Wayland? I don't know, who's responsible for the cursor? Who do I have to fire around here? I don't know. Someone's fired, I don't care, someone's fired. At Wayland or X11. Fuck it, someone's fired on Microsoft. Yeah, I agree. Screw it. All right, so I just did variable definitions with var. These are global variable definitions. And constants definitions with const, only set once. And now we're doing function. Technically, I had function something like 30, 45 minutes ago. The reason I removed it is, of course, I had functions where this whole thing was part of the lambda. We don't want it to be part of the lambda. We want it to be part of the function. Right? We want to define them like this. We don't want to use the word lambda here. That is annoying to do. We don't want that. So, it requires a little bit more processing, but not a whole lot. Fun. I'm also going to include macro, though I'm not going to do anything with the macros, because I need to actually look into how macros truly work. I've used them a few times, but I have to say it's mostly been just vibing, thinking this is how it should be, probably. Sometimes I'm right, and sometimes I'm like, I think I can use a function here, and then I end up using a function. So, yeah, I'll have to look into it. I'll have to study it. But, yeah. So in that case, let me not include an element of the language that is not actually used. Let me not include them for now. Maybe play around with macros in Common Lisp in a minute or two to figure it out. But anyway, when the expression that we have begins with fun, we get the name of the function from here. Then we are going to take the parameters of the function and the body of the function. And what we're going to do with this is we're going to construct a lambda, the anonymous function for it, just with these elements. Yeah, that's probably the easiest way for me to handle it, is to just construct a lambda. Once I have that, just put the lambda into the environment, modifying the environment, and the returning nil. All right. So our expression looks like this. Where are you at? Our expression looks like this, where car of the expression, head of the list, is this one. We have already processed that. So we get CDR, the rest of the expression, and car of that is the name. All right. So to get the next elements, we do a... Do I maybe want to optimize this code in the fucking slightest? Something like this, maybe? So I've gotten the next element, which is the name. I am now going to get the next, which contains the arguments and the body. All right, so the arguments of that is just the car of next. And the body is the CDR of next. That's it. That's all I need. Then, to create the lambda, I'm going to use a helper that I should probably don't think I have created yet. I will need to create a helper. Here, Emmanuel Gen. Code gen make lambda with a code gen args and a code gen body. Okay, so that's what we're going to be calling. its implementation is going to look like this thing, where we will put I should be able to actually call CodeGen register element, yep, into S of type sem rule lisp file. No, not element, register rule. Subrule? Subrule. And what is it going to be? It's going to be a make ID atom with lambda. The next one after that is going to be the arguments. The next one after that is going to be the body. So we're essentially going to be creating a list of these three elements and returning it. Hopefully it's that simple. So that's how we make our lambda. Make lambda with the parameters and the body. Put it into the environment. And it should be possible to access it through this call to fib. All right, no, that did not work. All right, so let's see that lambda that I constructed. Do you have quasi-quoting in this list? Not yet. Another thing that's gonna stop me from doing that's the one with this quote, right? Let me just confirm. That's one thing that's stopping me from doing macros properly. I have quotes, but I don't have quasi-quotes or unquote. So we'll need to add that. Keep in mind, until this stream today, what I had was Lisp 1.5. Does Lisp 1.5? Maybe it does. Again, I read part of the manual, but I didn't finish reading the manual, so maybe it did have... I mean, it has quotes, so maybe it has quasi-quote. No, I don't see it here. Unquote? No, but it does have quote. It only has quote, actually. But it also has eval quote, which I hadn't heard of. Defined by using two main functions called eval and apply. Oh, it's just eval and apply. Okay. Hi, Stony. How you doing? Yeah, so the entire language definition that I have is this. Well, now I have more, obviously. But until the beginning of the stream, I had this. And for like an hour after that. Because I was doing other stuff. Alright, so my lambda looks like this, and I'm not entirely sure that's what it's supposed to look like. That's one way to find out. When I evaluate the lambda, it says unknown expression. Wait, symbol not found A, symbol not found B. Eesh, what are you talking about? Oh, I did something wrong. I did something wrong here. Now, is this lambda correct? It resolves to... Thank you for that. That was very helpful. That's exactly what I was trying to copy. I mean, it overall looks okay. What does this parenthesis match to? I do find this print... I haven't found a convenient way to print for debugging inside of the... this is the closest I've come, but I still find it a little bit hard to read sometimes. Especially when expressions get this long. Like, I think I did it right, but I'm not sure. When I evaluate a lambda, which is in apply, what do I do? Alright. I'm going to first off get the arguments of the lambda, which is not what we're dealing with right now. And then car, which is going to be this thing. CDR is going to be this thing. CDR, which is going to be this thing. That seems correct. No, I specifically want to keep the dots. Because I need it to... to know when there's a nil expression. Right? Like here, for example. This is the second part of an expression, which is empty. So yeah, the dot I actually got from the manual itself. I just don't remember what exactly it meant. But yeah. What does self-hosting mean? Self-hosting in this case just means that something is able to run or compile itself. It depends on like what you're talking about necessarily, but yeah. Inline const, is that what it's called? Alright, so looking at it like this, I do think it's correct, but maybe there's one too many parentheses here? There is probably one too many parentheses here. What I should have done is this. Which is add the body, append it to the arguments, to the end of the arguments, which goes after the arguments, obviously. That seems almost better. Almost better. Alright, I'm gonna comment out you2. It's still not running the function, yeah. And saying symbol not found for these? What do you mean symbol not found? Eval error null pointer. Okay, so that is still not correct. No, that is still not correct. Hello, Kong. I am making a language, Lisp dialect. Alright, here's what we're gonna do. Can I actually go back to this thing? Thank you. That's exactly what I need. So just copy that, comment out everything else. Keep just this. All right, and in the label, here, this is the lambda. Print that. All right. That is the exact same lambda, mind you. So that's going to be very convenient for me to look at. Thank you. All right, so my lambda is supposed to look like this. Now we bring back the rest of the code. Get rid of this. I'll have to figure it out, but later. And this is the lambda that I am creating. Host machine is Debian. Alright, so already I can see this one's a little bit longer than it should be. Immediately I can see the difference. Alright, so first off, that thing that I did there at the end, this thing, that has to go away. Shouldn't be like that. This looks closer to what the lambda should look like. Almost there. Almost there. Looks like there's one too many elements now. Yep, that shouldn't be there. Is the grammar of the language from scratch? It's Lisp, so not really, but yeah. In the sense that Lisp already has some way of doing things, and the keywords that I use are different. Some of the behaviors might be slightly different, but it is pretty standardized because of the way that Lisp works. Alright, so yeah, the problem is this parenthesis here should not be there. Now, the reason that parenthesis is there can I just... Do I even need to do this, mind you? Do I even need to do this? Like, do I need to separate the arguments and the body? Like I'm doing. Right, because this is already the list that I'm trying to recreate. I'm just taking the first element from that and eliminating it, and then taking the CDR from that. That's not necessary. And just do that. And that looks worse. Almost there. Almost there. I switched the problem now to being here. Now when I made an ID atom, right, can't I just... Yeah, instead of using this, which is kind of an obscure way of doing things. Obscure. It's just not very clear what's happening here. I'm just gonna do it the correct way, which is S expression code from S pointer. Code car that code CDR that. There's my lambda. All right. Don't you love when you fix a bug by actually simplifying the hell out of the code? That is a great feeling. And there you go. Perfect match to what the lambda should have looked like. Boom. All right. We have fun. We have fun now. We have fun. Isn't that beautiful? We officially have fun in the language. Take that, Rust. Rust has fun. We have fun. Alright, although I did see that something about these two variables was breaking. Symbol not found A, symbol not found B. Oh, it's not breaking. No, wait. Rust is taking the U out of fun. It's taking the fun out of function, really. I go with the worst way of adding printf in all the functions. Nah, I do the same. Literally, GDB is the most useless program I have used in a long, long time. And it's the only one that I can use. So believe me. Printf, it's a lot better. Okay, I was about to say those errors are actually expected. One of those errors is actually expected. I know, never mind. Never mind. I was running so these errors are expected because in order to assign a constant value, we only assign it once, so we have to check if it has already been assigned. And the first time it hasn't been assigned, so it produces that error, which I need to silence in the compiler at this point. But no, let's do that. Let's do that. Let's keep it like that. Or actually, yeah, no, let's keep it like that. There is like a stack trace mode, so I do want to keep that. Right, so keep it only in that case. Alright. The reason that the error was showing up for both a variable and a constant is it should have showed up only for the constant. But I was running the check, even though I was ignoring it completely when I wasn't inside of a constant. Okay, so we're good. We have constants, we have variables, we have fun. We are missing macros. Again, I need to study them a little bit more, because I do understand them. But it's interesting the way that they work. Although it is super, super powerful, so I definitely want my Lisp to have macros. But at this point, we have. Let me look at a normal code base like this. A build system, because this one's just kind of supposed to be declarative, just declaring stuff, just calling functions. This is a proper code base. Okay, so this has packages, which I have to say, it takes a really stupid approach with packages, Common Lisp, which I also find that, well, with the namespace of packages specifically, which I also find that C sometimes is a little bit ridiculous about. And it's the fact that inside of two completely different files, in C, I can have two variables with the same name, and guess what? I'm not allowed to do that. But I'm also not allowed to reference them from each other's files, so it's like the worst of both worlds. It makes perfect sense. It's not a stupid decision. It just feels ridiculous when you put it that way. Like, oh, you can't use them with each other, but at the same time, you can't have them have the same name. I get why, but it feels silly, even though it really isn't. With Lisp, maybe I'm misunderstanding just the way that I'm doing packages, but I cannot have inside of my package a name that is also used inside of another package. Which makes me wonder, why use packages at all then? If I still have to use completely unique names. Because like what some languages do, for example C++, like you have a namespace, like hello, and in here I declare a class called world. Look at me saying C++ is good, C# is good. Did I say C++? I meant C#. Alright, and then I can have another namespace called hello2 with another class called world. And inside of my code base somewhere I can have using hello, using hello2, which is just saying these two namespaces, include them in this file. And if I then try to create a new class world, it will tell me that there's ambiguity between these two, and I have to specify the package. So I have to explicitly do this or this. Whereas if instead I only use one of them, then there's no ambiguity, I don't have to do this. But I am allowed to have two classes with the same name. As far as I can tell, I'm not really allowed to do this in Common Lisp, which feels really weird. It feels incredibly weird. That feels like a limitation. I'm not sure. I don't particularly love working with packages. I almost regret working with a package in here, because all it feels like, it just limits me as the developer of the package. I have to export functions that I want to be able to use. I have to either like explicitly say that I'm going to be using this package, or append this to everything. And I don't see the benefit of the package. But again, I'm probably misunderstanding what the point is, because the way that I see it, it has zero benefit. I don't think that's accurate, but yeah. Going to add macros in the language? Yep. Lisp is actually super macro-like. It's a lot about macros in Lisp, so... Now, I don't think there were macros in the original versions of Lisp, which is why they're not already there. Since again, what's currently in the repository is actually Common Lisp, not Common Lisp, Lisp 1.5. Probably not a super spec compliant implementation, but still, a pretty good implementation, pretty close implementation to Lisp 1.5. Whereas what I'm making now is my own dialect. Yeah, we need to see how these macros work. Now, let's... Do we still have a playground in here? I feel like I deleted it. I did delete it. Alright, but I can recreate it. Playground, just a folder called that, where I can put whatever I want. Let's do macro test.lisp. And we're gonna write some macros in here. Alright, so here we rely on the sabbatical script playground macro test.lisp, which will do nothing. Alright, so I can define a function, defun, the opposite of mine. Mine is fun. Theirs is defun. Alright, my function is going to be called fn. It's going to have an argument a, and it's going to produce a as the result. And I can technically do the exact same thing in a macro, right? Def macro, not the macro. F2n, what the hell? That was supposed to be fn2, but got it wrong. Anyway, I'm going to run fn with a value of 1 and 2n with a value of 1, neither of which is going to print anything because, yeah. One and one. Okay, so far so good. Now, is the repo open source? You know, I think it doesn't have a license. So technically, you're not... Oh, it does have a license. Yes, it is then. GPL3. Although most likely, I will need to do an exception like I did for the operating system. There, I had to specify that you have to... your projects have to be open source if they're derived from the code, unless you link against my library for the purposes of syscalls. It sounds like I'm probably gonna have to do something similar for a compiler, right? Because my intention is if you take the code of the compiler, you should open source it. And if you use the compiler to compile something or to interpret a Lisp script, then no, you don't need to do that. All right. I had an idea for what I wanted to do for the macros. All right, yes, I know. All right, so what if I want my macro to just add two numbers together? I'm going to hardcode them. Right, with no arguments. Although I am going to use the argument, so I'm going to keep it. All right, that adds the two numbers together. Can I do this, for example? No. Common Lisp A is undefined because it doesn't know that it is a function. Right, so I'm pretty sure what I need to do here is this and this. Yes. Okay. All right. Which is the same as what was being talked about before, quasi-quote and unquote. Nope. Must have done it wrong. Illegal function call. Then I'm actually not sure how it works. Comment not inside a back quote. So that's not a quasi quote. It's a back quote. Is that a word that I can use? No. Alright, so. Back to this working example. Both interpreter and also compiler. So the repository is for it initially started off as a compiler. Then I made it so that you can define the language that you're going to be compiling. Not at runtime, though maybe that will be the intention eventually. But essentially it makes it very easy to compile different languages by just a little bit of configuration. And then it can also compile, it can also work as an interpreter. Because the two types of expression that exist in Lisp, which has the atom and the S expression, are just bytecode for the same kind of virtual machine that I use for the compiler. Which also should make Lisp the meta programming language for the compiler itself, but that's not the same thing that I'm doing here. All right, so it's very hot in here. It's getting really annoying. But, by the way, let me just link you manually to On YouTube, I can have the repos that I'm working on, though I sometimes forget to update it. On Twitch, you can't really have a description, so yeah. I will have to update like the commands and stuff. That's very annoying to do. Anyway, so that's not what I thought. The back quote and the quasi quote are different things. A back quote initiates a quasi quotation, so it is a quasi quote. Alright, so but apparently I'm not allowed to use just the word quasi quote. Maybe Common Lisp just doesn't use that word. And the only reason it became yellow is because the syntax highlighter sees it as one, but it isn't. Alright, but anyway, what I'm doing here is that you can escape, which is going to be very powerful for macros. You can escape an expression so that it doesn't get evaluated. For example, back to my Lisp, which prints every expression. That's very convenient. Actually, hold on. There's no need to go back to my Lisp. Let's do this. Why would A be defined, brother, when I'm quoting the whole thing? Alright, either I don't understand how quote works, or Common Lisp doesn't understand how quote works. Or maybe I'm just not supposed to use it inside of a macro. That's it. Okay. So there's limitations for that, which... okay. But anyway, quote prevents... what is it called? A quote prevents evaluation of an expression. So normally, when you run the function f2n, which, by the way, I don't need the original function anymore, so I can get rid of it. And just call this one function, right? When I call fn with any variable, this value here doesn't matter right now, what it's going to do is it's going to evaluate the body of it, and it will not really work like it should, I believe. I don't believe this is going to give me the result that I expect. No, it's going to be an error, right? Because it's trying to run a function called a. And it's like, bro, what the hell is a? A is not a function. A, it's a parameter that you passed into the function. So I can't really do this kind of thing, where I'm doing like mathematical operation. That's what it is, right? Let's call it that. Let's call it math. Right, so I want to do math of some sort, and I can specify the kind of operation that I want to do. Let's maybe even put the numbers here. I can't really do that. But I'm pretty sure if I use a quasi-quote here, and then I use a unquote here, no, I still don't know how it works. Because this is not a thing that I can do outside of macros, I believe. But I'm trying to figure out what makes macros different from normal functions in terms of like... Oh, that worked. Kind of. I mean, that evaluated to something. Just not correct. Alright, can I do describe, is it? Define, maybe? No. There is a function in this interpreter to be able to describe an element. It will tell you if it's compiled or if it's just part of list. It shows you the implementation of an identifier, but somehow we cannot find the fucking name of it. Is it describe? It's not called describe, but maybe it's something similar. Describe? Oh, okay, you have to use this. Okay. So describe and then def macro. And it fails. That looks like it should have worked. Undefined function. Whatever, man. Def macro implementation. Yeah, break stream elements? I have no idea. I hate that thing with a passion. It only works on Sundays on YouTube, for example. Okay, I swear to God, what do I need to do to use to find out how this is implemented? Describe doesn't work. Google doesn't work. Well, DuckDuckGo doesn't work. Google probably doesn't work. Oh, very helpful, yeah. Thank you. Def macro in syntax case is easy. Implementing syntax case in def macro isn't. I just need to understand how the damn macro system works. This is apparently impossible. Common Lisp macro system. Fuck's sake. A macro is an ordinary piece of Lisp code that operates on another piece of putative Lisp code, translated into a version closer to executable Lisp. That may sound a bit complicated, so let's give you an example. You want a version of setQ that sets two variables to the same value, so you write this thing. When z equals 8, then both x and 11 are set, x and y are set to 11. It should be obvious that we can't define it as a function. because it doesn't know what values it's supposed to set, so you use a macro instead. When you see this, treat it as the equivalent of this. All right. So you would define it as the word progen, then a list. All right. Okay. So that makes it a little bit clearer what's going on. All right. So is this really how you would define this macro, though? I've never seen a macro use this many words. It's kind of ugly, but I'm gonna do what they're doing. All right, so let's do that. Okay, so we're gonna define a parameter x, value 0, define a parameter y, value 3, and then we're going to set q2 x and y to plus 3 and 9, which is going to be 12. So it's going to set them both to 12, and then we're going to print x, and then we're going to print y. All right, so without running this thing, which I haven't implemented yet, we have 0 and 3. Okay, yeah, I was wondering why. Yeah, they're different. Obviously, they're different. All right, so to implement this macro, def macro set q2 takes 3 arguments, value a, value b, and the value, the actual, well, variable a, variable b, and the actual value that you're going to be writing. And again, it looks very idiomatic, but that feels very weird. But yeah, what they're doing is creating a list of, first off, the word progen, which just defines the program pretty much. Inside of that, 2 different lists of set q, which sets the parameter, passing a, which is going to be the first parameter to be set, and v, which is going to be the value to set. Do the same thing with b. And now they're both 12. All right. So I can also do this for the macro if I just use quote. Works in the same way. This thing is just syntactic sugar for quote, which I'm going to need right now because I do not have the symbol. I don't want to have to add it yet. Yo, what's up, Jester? It's been laying like that since the stream started, by the way. Hasn't moved an inch. Alright, so far so good. And doable in a way that I know how to do it. However, can't I just use a function here? If I do this, can I do it? Also no. Okay, so again, my question was, what does def macro look like internally? How is it implemented? But that's the answer that I'm never gonna get, apparently. Because again, this thing doesn't feel like giving me the answer. Okay, this terminal just doesn't work anymore. Cool. We're at the part of the stream where everything starts breaking. I have literally used this function to describe this exact function that I just looked at. I have to say I don't understand why it doesn't work anymore. Right. So I have to do it like describe and then this thing. No, that's not how you do it. It's describe and then this thing, now with the right symbol. All right, finally. So that is the definition of plus. Well, why can I not do the same thing for def fun? And why is it an error to do that? The fun is a macro. Okay, so describe macro. It's giving me the definition of what a macro is. I am going to... Don't say that. All right. What the fuck is happening anymore? I'm at that point where search engines don't work anymore and I cannot continue searching the thing that I want. This is so utterly useless. I am trying to find how to describe a macro within Common Lisp, where describe is a function within Common Lisp. And the fuck ass Google is giving me the description of a macro, which is not what I'm asking for. It's not even AI, it's featured snippets. This thing is creating a it's just crashing for no reason. Like, did you need to crash like that? Did you need to do that? No. It's just very annoying, very rude of you to do that. Like, if the thing that I'm trying to describe is not a function, just tell me that. Don't crash. That is very rude. Um, it's a macro, not a function. You could have also told me how to implement it, or how to describe that, how to look at the implementation of that. Because I'm literally just trying to understand how those are implemented in Common Lisp, but apparently this is genuinely impossible. Remember when you would search for something and you would get the result that you're looking for? Which you know is out there. Back when Google was not pretending to be stupid. Back when Google actually was pretending that they cared about giving you a useful experience. Alright, good thing there's an ad break coming because I'm genuinely tired of Googling shit. I'll be back in 3 minutes. Okay, um, I'm back. And do you remember when you would do research and it would just work? Google actually worked? Because I'm starting to forget. Google, DuckDuckGo, all these engines. It is genuinely impossible to find anything nowadays unless you go specifically through an LLM. Which is certainly not by design and is certainly not a really, really, really bad thing for finding out information. Definitely not, nothing, no problem there. Anyway, I'm trying to do something as simple as finding out how something is implemented in Common Lisp, which is something that Common Lisp itself should be, the interpreter itself, the REPL that I'm using, should be able to tell it if I knew how to ask it, which I'm trying to Google, and I cannot find an answer to that. So I'm also trying to directly ask Google how to do something, which it also doesn't have an answer for. And at this point, I do ask myself, what the fuck am I supposed to do? How do I Google something and get a response? Or DuckDuckGo it and get a response? This is a genuinely impossible thing to do nowadays. Because the second that you move away from Googling the most basic thing ever, you will not get a valid response unless you are willing to ask the AI. Wonderful. Wonderful, wonderful. So anyway, I don't know how to implement macros in um, Common Lisp. I was trying to find out exactly how define function and define macro are implemented in Common Lisp so that I could look up their implementation and understand what def macro is doing internally. I do not know how to do this. I am actually unaware of how to do this, and I don't have the resources to look it up unless I want to use LLMs. It is also something that doesn't come in the manual because this is something that was added to the language, I believe, after Lisp 1.5. So I don't know what to tell you. How will I implement macros in my Lisp? I have no clue. I have a grand total of 0 clue on how to do that. Because again, the tools that have always been there for researching things are no longer there. And for that matter, the one tool that does exist could very easily just lie to you, and there's no real way that you can know how unless you try to do what it tells you and you find out that it's actually not true. Yeah, so we're gonna move on. We're not gonna have macros for the time being, I guess, because there's literally nothing else I can do. Fucking hell, man. Absolutely ridiculous state of affairs right now. Alright. So my language has variables, functions, constant values, does not have macros, will not have macros, until I manually learn how they work entirely on my own, through no external help whatsoever, I guess. Maybe tonight I'm gonna be dreaming, and it's gonna come to me in a dream. Maybe John McCarthy himself is going to appear in my dreams and explain to me how macros work. Yeah, that's probably what's gonna happen. That's probably the best case scenario here because, again, fucking ridiculous, man. Fucking ridiculous. Oh, but AI is so useful. Shut the fuck up. It's literally not. You can lie to people who don't use it, but you can't lie to people who use it. So let's genuinely stop pretending that AI has any kind of use, and for the love of God, that it hasn't destroyed literally anything that was useful, that was there before. Anyway, wishing Google a speedy downfall. DuckDuckGo, you can DuckDuckGo away too, honestly. What the fuck? Yeah, whatever. Anyway, I still don't know how I'm going to find out how macros work when every kind of research that I do is genuinely impossible to get a result on. So what's left to add in this language now? If I have functions, I have variables, I have constant variables, or values, not variables, obviously. There is let. Let is similar to defining a variable, but you only define it within itself, within the scope. So let is to variables as label is to functions. Right, I can define a function and it's going to be available outside of the scope here of the function itself. Or I can use a lambda, which is only available within its scope. I can use label to give the lambda a name. And then use it only within here. Let is similar to that. Let allows me to Define. It does have some kind of weird syntax, to be honest, which... Do I care to include it like that? I don't know. But anyway, let works like this. You define variables in here, variables, multiples, and then they exist within the scope. But you declare each variable like this. I have to say I was never a fan of this. Then again, the code that I have is not particularly um, complex. So I'm not defining a whole lot of hold on, first off, let me find some actual code with it to make sure that this is correct, because I'm not sure that it is. There should be some lets in here. Yeah. Right, because you declare a variable, you have to give it a value. You have to always give it a value. It's not like you're just declaring this exists. No, you declare it with a value. Right. So even though you can override that value, I believe. So you do need to do this. All right, so then this kind of syntax makes sense, except when you have multiple variables, it makes sense. When you only have one variable, you have this double parenthesis stuff, which confused me at first, but I guess makes sense. Hello, Kayal. All right, so I think I am going to keep it like this, because it makes sense. Also, I'm going to use different names, like X and Y, 3. And inside of here, I'm going to do add X and Y. That should produce, you know what, 9 and 10. That should produce the result 19. The reason is that I already have... No, I don't have anything with 2 and 3, so it could have worked, but whatever. Alright, so what's going to happen here right now that we don't have anything is... It's not going to do anything, it's going to tell me that it's null. That makes sense. Alright. So, a let. A let is one of these. By the way, I think I showed this earlier, but I'm using everything as case insensitive, so that technically means that you can write this. You can write the old style of Lisp. Please don't do that, but you can. I guess you can. Alright, so it's something similar to before. I think I can get away with just doing this. Creating a local environment, which is a combination of the existing environment and the new variables. The new variables which come directly from car CDR of the expression. That is to say, the second argument of the expression. This entire thing. I hope I'm doing it correctly. I guess since I'm running it here, this symbol will break if I'm not doing it correctly, and the function call will break if I'm not doing it correctly. Alright, so that should be defining it. And then I should be able to eval the CDR of the expression, that is going to be this whole thing. CDR again. That is going to be this and any other function calls after that. Or any other expressions after that, I mean. With the environment being local. The local environment only. Alright. Is it that simple? Unknown expression add in apply. Why Lisp for an operating system? It's Lisp for scripting an operating system, not for the actual operating system. Although there are operating systems written in Lisp. For the Lisp machine mainly, but that's not what I'm doing here. They're also all known Lisp machinists anymore. What was the error? Unknown expression? Add in apply. I understand. This is what I'm passing to eval. I'm not sure why, but I shouldn't have to car it. Like if I do this, this will probably work, but other expressions will not. No, it still doesn't work actually. Alright. Hold on. This I'm doing wrong, clearly. So the body of the let expression, I'm gonna print that. Yeah. Right, I'm not really supposed to call eval. I'm supposed to call eval list. Evlist on it. Which evaluates it like a list. That's how you do that. Though it still fails. But at least that is the correct way of doing it. Math error null car. Null car. Null car. Your mom's null. Alright, so this is my new environment. Inside of the let, I have access to all of these things. And it feels like there's too many parentheses here. There's one too many. There's one too many, yeah. It's not good. So one expression contains as the first element this thing, as the second element this thing. That feels correct though. No, it's not, it's not, it's not. Okay, so essentially I have X and then Y. And as I'm taking that and combining it with also the environment, that ends up adding one too many um, arguments to it, I believe. One too many parentheses, I mean. So, the correct thing to do, probably what pair list is doing, yeah, the correct thing to do is, I think, to call pair list on it. Although, no, it isn't. Pair list is taking two lists and combining them together. It's a zip function. What I need to do is similar, but not quite like that. What do I call this function? Let vars is not the correct name. Yeah, I'm gonna call it this for now. Where essentially you take the car of X and then you call it with the CDR. I'm starting to get the feeling that the way that I did my code generation is not the lispiest. Like the way that I go from the parsed code to the IR, which requires me to do very weird operations like this one, where if it was done properly, this operation does nothing. But it's not done properly, so it does something. I guess. I'm not entirely sure. Okay, that should be correct. And that should be my local environment. Which it is. And now nothing is being printed. That's concerning. That's very concerning, actually. How did this happen? No, I'm very confused as to how this happened. I am incredibly confused as to how this happened. Okay, that looks better. Kind of. So now I'm evaluating one, but it works. I don't even understand what's happening anymore. Hold on. Um, what's up, Vista? Alright, this is so confusing. Uh, what did happen? So this fails because the expression is not actually something you can evaluate, but what? If I evaluate this expression, then nothing gets returned. Ever. Even though there's no error. Uh, what? I'm lost as hell. Alright. So, start by looking at the local environment that I'm passing into this function. Marginal print. Local. It should be variable A, function fib. No B, because that's not there yet. And I'm actually going to remove the function because it's going to like add all this to the environment, and that makes it very hard to read. All right. So we have value of x, value of y, value of a, written twice because it is a variable that gets assigned twice, and I'm really not doing anything about that. Don't care much for that. Right now, that's fine. But that is the correct environment. I do think that's right. All right, and then the body of what I'm trying to run is this, a list of items.